Hello students, so in our previous lectures, that is lecture number 228 and 230, uh, 228 and 230, we have discussed about Lagrangian polynomial, and we have derived this equation previously as a Lagrangian polynomial. You can look into these lectures to find out the values of these coefficients v1, v2 and v3. Now, the polynomial equation, this equation can also be written in the following way. We can write this equation as fx is equal to fx1, which is the value of v1, plus we'll write delta t f1 x minus x1 plus delta d2 f1 x minus x1 divided by x minus x2. This is quite interesting. When these functions, function delta d and delta d square, these are called divided differences. Now let us try to understand what this divided differences is. To understand it, we first need to write the values of the coefficients once again. So b1 is of course equal to fx1, so there is no problem in that. The value of b2 was fx2 minus fx1 divided by x2 minus x1. So, and the second term in the polynomial series, that is fx, was b1 plus b2 x2 minus x1, x minus x1, and it has now been replaced by this term sigma d f1 x minus x1. So b2 has been replaced by sigma d f1. Now this is actually this difference x2 minus fx1, and this function b2, this function f1, is actually a function represented by 1 by x2 minus x1. So if it is fx minus x1, it means it is x minus x1 divided by x2 minus x1. This is what it means. And similarly, for the case of the third term, that is b3, there were two terms involved in it. First, it was fx3 minus fx2 divided by x3 minus x2 into x3 minus x1 minus, if it was fx2 minus fx1 divided by x2 minus x1 into x3 minus x1. Now this has been replaced by sigma d square f1 x minus x1 into x minus x2. So let's now write this divided differences in a tabular form. So for fx1 is the first term, and sigma df1, which is equal to b2, this is equal to fx2 minus fx1 divided by x2 minus x1. This is the first divided difference, and the second divided difference fx for fx2, that is sigma d square f1, which is equal to b3. It is the previous term that we have already told. So let us write this one once again. So this is sigma d f2 minus sigma df1 divided by x3 minus x1 by sigma df2, we mean, if you look closely here, had it been f2, it would have been x3 minus x1 divided by x3 minus x2. So instead of writing this, we have written as sigma df2, and this is the previous one, sigma df1. And in the same notion, we can also write the value of for fx3. If we go to the higher order, that is, we can write it as sigma d f2 which is equal to fx3 minus fx1 minus fx2 divided by x3 minus x2. So this corresponds to this value. So we can write it in a generalized way. We can write the value of fx as equal to fx1 plus sigma delta d f1 x minus x1 plus sigma d square f1 x minus x1 into x minus x2 plus sigma d3 f1 x minus x1 x minus x2 x minus x3, and we can keep on doing this till it is sigma d n minus 1, which is equal to f1 x minus x1 x minus x2 till x minus xn minus 1. Let this a little clearly. So it is x1, x2 and xn minus 1 for sigma d if delta d f1 n minus 1. And so this term sigma d n f1 is simply equal to sigma d n minus 1 fn minus sigma d n minus 1 fn minus 1 divided by xn minus x1. So let's take an example. Now suppose we have been given the following values x and fx. The values of x are minus 3, minus 1, 0, 3 and 5, and the corresponding values of x are minus 30, minus 22, minus 12, 330 and 3, 4, 5, 8. And we need to fit at the polynomial and find the value of f at 2.5. So this is our task. So we will write the divided difference table. So we will first mention x here, then we will first write fx, then I will write sigma d f, then sigma d delta d square f, so it will sigma delta df, then delta d square f, then delta d cube f, and delta d 4f. 1, 2, 3, 4, 5, 7, 2, and 1. So, and so first we will let's write here x. So it will be minus 3, minus 3, minus 1, 0, 3 and 5. So the values that we will get is for these two values. For these two values, we will get a value 4. For these two values, we will get a value 10. For these two, we will get a value 114. And for these two, we will get a value 1564. And similarly, for these 2, 4 and 10, we will get the value 2. For these, we will get the value 26. And for these two, we will get the value 290. For these two values will get the value 4. For these two will get the value 44. And lastly, for these two values will get the value 5. So these values are based upon this equation. First we find sigma d of 1 and then we'll use it to find the other values. So the putting this equation into the picture, that means we'll now write fx as equal to fx1 plus sigma df x minus x1 plus sigma delta square df x minus x1 into x minus x2 and sigma d3f x minus x1 x minus x2 into x minus x3 and sigma d4f x minus x1 x minus x2 x minus x3 and x minus x4. So putting these values, now x is equal to, find the value of 2.5 fx. So f 2.5 f2.5 happens to be equal to the first one, that is minus 30 corresponding to fx1 plus it will be 4, that is sigma df into x plus 3 plus the second value will be 2 x plus 3 into x plus 1, then it will be plus 4. So this 2 comes from here, so this is 4, then we are taking this 2, then we will take again 4, and then we will again take 5. So it will follow this path, any one of the paths. 4 x plus 3 into x plus 1 into x plus it will be 5 x plus 3 x plus 1 x into x minus 3 and putting the value of x, which is 2.5, we ultimately come up with the value as 102.7. So this is the value.